Okay, I want to look at the graphs of equations. And basically, in algebra, we deal with three equations, three types of equations. One of them is a linear equation, and it's in first degree. It could be two or could be three variables. If you were in college algebra, we're dealing with three variables right now. It's pretty hard to graph in three variables on a two-dimensional paper. But you could look at y equals 7/4 x minus 7, and you guys can plot that now. You simply come down to -7. You know that that the slope is 7/4, and you know that the y-intercept is -7. So you'll simply come down 7, mark a spot, then you'll go over 4 and up 7 and mark another spot and draw the line through those two. That's a linear equation. A quadratic equation is of the form y equals x squared minus x minus 2. It's a secondary equation in two variables. Now, we can look at something like, I don't know, say x squared plus y squared equals 25. Now, we're not going to look at this kind of problem, but you could, and basically what that turns out to be, this one turns out to be, is a circle with a radius of 5. So this would be 0, 5. This would be 5, 0. This would be -5, 0, -5. Right here, 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 and this would be -5, 0. And you would end up with a circle. Now, that doesn't fit with what we're doing. I just wanted to show you that it could be that both of these are second degree. Well, we're not going to deal with those. We're only going to deal with this one right here eventually, not today. Okay? You can also look at a third degree equation. If I multiply three of these variables together, I'll end up with something like, I don't know what it would be. I'll go ahead and expand it for you just to show you how to do it. Let's multiply these two right here. So that's going to be x squared plus 5x plus 4. And I'm going to multiply that times x minus 2. If I multiply by x, I will get x cubed plus 5x squared plus 4x. Now I'm going to multiply by -2. -2 times x squared is minus 2x squared. -2 times 5 would be -10x. And -2 times 4 would be -8. So if I add those together, I'll end up with y equals x cubed plus 3x squared, x cubed, not squared, plus 3x squared minus 6x minus 8. That's what this equation, if I plotted the points, would be this shape. So if I pick out a point on here, it doesn't matter what that point is. Whatever this point is right here, it's going to be negative x value and a positive y value, whatever that happens to be. If I plug that negative x into this equation right here, I will get that value of y. That's the concept. Now, again, we're not going to be dealing with this one so much. We will be dealing with the quadratic sum. That was just to show you where we are, what we can do. What I want to look at is now, I've got an equation. I can plot the line. Suppose that I've got a point, and this point is 3, -2, and I've got a slope of 2/3. How do I find the graph, or excuse me, the equation of that line? Well, you have something called a point slope method. That's what your book teaches you. And it's y minus y1 equals m times x minus x1. All you have to do is plug y1 from this value right here. So y minus y1, there's your y1, equals m, which you know is 2/3, times x minus x1, which is right here. Now let's simplify that. That would be y plus 2 equals 2/3 x minus 2/3 times 3. And you can see that these two are going to cancel, so I'll end up with y plus 2 equals 2/3 x minus 2. If I subtract 2 from both sides of the equation, I get y equals 2/3 x minus 4. There's the equation of my line. That's the slope-intercept form. All right, now I want to show you that what you can do is, let's take this equation and let's subtract the 2/3 x from both sides of the equation. So I've got minus 2/3 x plus y equals minus 4. Now what I want to do is I want to multiply everything in here by that denominator of 3. Well, if I do that, the 3's cancel here and I get minus 2x. I'll get plus 3y, and I'll get minus 12 over here. Just multiply all three parts by 3. Generally, we don't like to lead with a negative sign, so I'm going to multiply that by -1. And the effect is that it simply changes the signs of everything. So that's going to be positive 2x minus 3y equals positive 12. And this is the standard form. So this equation right here is exactly the same as this one right here. Those two are the same line. So you can put it in slope-intercept form, or you can put it in standard form. Now, I'm not sure how your homework is going to be. Sometimes your author asks for standard form, sometimes he asks for it in slope-intercept form. Now, we can solve either way. It just depends on what your author wants to do. Okay? What I want to show you now is the way that I was taught. I had an instructor by the name of John Atherton. He was absolutely brilliant. And he said, let's do it this way. The slope-intercept form is y equals mx plus b. You have a value, our point was 3, -2, and the slope was 2/3. His point was, here's a value of x, here's a value of y, and here's our value of m, so plug it in here. -2 is a value of y, 2/3 is a value of m, 3 is a value of x. The only thing I'm missing is b. So let's solve it. Minus 2 equals 2 plus b. B then is -4. Well, if I know the slope and I know the y-intercept, I know that y equals the slope 2/3 x plus b. And that's the same thing I've got over here. 2/3 x minus 4. Now you can choose whichever one is easier for you. Like I said, John Atherton was my instructor in high school, and this is what he taught us to do. I find this much easier than a point slope. This seems awkward to me. Maybe it doesn't to you. And it may very well be that's just the way that I learned it. Let's suppose that I have 2 points. And my points are -3, 4, and 7, 4. Okay, now I want you to think about for a minute the formula for slope. The formula for slope is m equals y2 minus y1 over x2 minus x1. And I said it doesn't matter which one you choose as x1, y1. If I've got a positive x, that's generally what I choose as x2. It doesn't matter, but this is the way that I like to do it. And this would be x1, y1. Alright, so let's plug it into this formula. y2 is 4 minus 4 over 7 minus -3. That's 0 over 10, which is 0. Okay? So what that tells me is the slope of a line with 0 slope is a horizontal line. It's a horizontal line. So let's think about this now. If I plot -3, 4, it would be something like here. Here's -3, 4. And this is the 0.74 out here ways. This is the 0.74. Well, clearly you see, if I draw a line between those two, let's see if I can do that without using that silly ruler. Now I got close. Okay, so I see that the slope is 0, and the y-intercept is 4. Well, if I plug it back into y equals mx plus b, what do I get? If I plug those values into the equation y equals mx plus c, I get y equals 0 x plus 4, or simply y equals 4. Okay, so here's the key. Anytime that you have m equals 0, that means the equation is going to look like y equals some number k, whatever that happens to be. Okay, that's what your equation is going to look like. By the same token, let's take a look at this one. Suppose that I've got the points 3, -2, and 3, 4. Those are the 2 points that I want. In this case, if you notice that the x doesn't change, if I do the slope here, it's going to be 4 minus -2 divided by 3 minus 3. So I get 6 divided by 0. And that's not defined. You cannot divide by 0. That's simply not permissible. Okay, now I want you to look at the points in this case. So if I go over +3 and down 2, this is the point 3, -2. And let's plot 3, 4. That would be somewhere up here. 3, 4. And you see that what you have is a vertical line. Okay, since x doesn't change, I can't use the same concept that I used over here because I don't have any way of putting in a slope. There's no slope that I can put in. So what I have to just remember is a vertical line is of the form x equals some number. In this case, x equals 3. Okay? This is a vertical line, and this one over here is a horizontal line. Okay? Those are simply two that you have to remember. That slope of 0 comes in handy sometimes in higher, more advanced math classes. That 0 slope has some applications. Very basically, I'll show you real quick. You don't have to remember this. I'm just going to show you this for fun. If I draw a line that's tangent right here, and I have a slope of 0, that's called the vertex. And we're going to look at other methods for finding the vertex. We're not going to use the slope method, but that's the concept. Here is a vertex here. Now this one's missing down here, but here is a vertex, a turning point, if you will, point of inflection. It changes from a positive slope down to a negative slope, from a negative slope to a positive slope in this arena. What I'd like for you to do, though, is simply just remember, if you will, that if you have 0 slope, it's going to be y equals something. If you have no slope, or if it's a vertical line, it's going to be x equals something. That's about all we can do with that. Okay, let's look at, let's suppose that I've got the points, let's say 4, -2, and -2, 5. Those are two arbitrary points. And what I want the equation going through those 2 points. Well, first of all, you have to understand, in order to have any equation, that implies that I must know the slope. That's a given. Well, I've got a formula for slope. That's y2 minus y1 over x2 minus x1. Well, let's see, this is 7 and this is -6, so my slope is -7, 6. Now what do I need? Well, I need a point. Well, you got 2, pick one. I like this one right here. Let's just take this one. Let's take 4, -2. I could use the other one, it doesn't matter. Now let's use the Atherton form that I showed you before. If I know that y equals mx plus b, and I know y, that's -2. I know m, which is -7/6. I know x, which happens to be 4. And I don't know b. So I have to solve for B. Now there's a couple of things you could do here. I'm going to show you a trick that I use quite frequently. Is I'm not going to multiply. Well, I guess I could. Let's go ahead and multiply that. That's negative 2 equals negative 28 over 6 plus B. Now what I would do is I would multiply everything by 6 just to clear that fraction. I could reduce this to 14 over 2, but I'm not going to. Let's multiply by 6. Negative 12 equals negative 28 plus 6b. All I did here was multiply by 6. 28 minus 12 ought to be about 16. Okay? Now I'm going to divide by 6, so 16 divided by 6 will be my value of b. And I want to reduce that. I can reduce it by a factor of 2 and call it 8/3. So now I know that b is 8/3, and I can take my slope, which I know now. I know my slope is 7/6. I know b, so y equals mx. So now I have my equation right here. That's the equation with a slope of or passing through 4, 2 and negative 2, 5. Those 2 points will satisfy this equation, and they establish the line. Okay, let's take a look at one more. Now, like I said, you guys can use the point slope method if you want to. I prefer the Atherton method. Let's try (3, 1) and negative 3, 2. Okay, first of all, I have to calculate the slope. Okay, now I said that I like to use a positive x, so I would call this x2, y2. That's just convenient for me. That's just something that I got in the habit of doing. It is 1 minus 2 divided by 3 minus negative 3. And that would be negative 1 over 6. That's my slope. Alright, now I need the slope at a point. Well, I like to stay away from the negatives if I can, so let's use this one right here. We're going to use this point. And again, I'm going to use the Atherton method. I know that y equals mx plus b. I've got a value of y, that's 1. I've got a value of x, which is negative 1/6. I've got a value of x, which is 3. And I've got a value, well, I know the value of b. That's what I'm looking for. Okay? Now here is where I would take and I would multiply both sides of this equation by 6. And the reason that I would do that is, if I do that, I end up with 6 equals negative 3 plus 6b. I don't have any fractions to deal with. I can now add 3 to get 9 equals 6b. If I divide by 6, I get 9 over 6 equals b. I'm going to reduce that by a factor of 3 to get 3 over 2. That's my value of b. And my equation then would be y equals m, which I know is negative 1/6, and I know that b is 3/2. And there's the equation of the line passing through those 2 points. Now, let's go ahead and take this equation and see if we can't change it into standard form. This is a slope-intercept. Let's go to standard form. Well, the first thing that I would do is I would multiply this by 6. So that means that 6y equals minus x plus, and if I take 3/2 times 6, that's going to cancel, that's going to cancel, and that will give me 9. Now I can add x to both sides, and I get x plus 6y equals 9. And that is a standard form. There's your slope-intercept, and here's your standard. Now again, you can use point slope if you want to. Yeah, I just find it awkward. This seems much more logical to me. You choose how you want to do it. Okay, that's all I have on equations. We're going to look at square roots and radicals of complex numbers next week. And as always, if you have questions, please email me or call or text or whatever you need to do to get in touch with me. And we'll quit at that point.